Hello everyone, I Madhura Patil of Bearing USN 2SD22EC033 is presenting a report on the topic ALOHA. Here, the main concept comes plot the characteristic curves of throughput versus offered traffic for pure and slotted ALOHA using NetSim. The main topic is we should plot the characteristic curves which offer traffic for pure and slotted ALOHA system using NetSim. Next comes, what's the question? What is NetSim? NetSim is network simulation software used for modeling, simulating, and analyzing various communication networks. It allows users to create network scenarios, model traffic designs, protocols, and assess network performance. How to install NetSim? Download the correct setup file, run the setup file as administrator. Next, follow the on-screen option. Here, it is must and should. We should follow the on-screen option. Accept the license agreement. Choose your desired installation path. Here, you need to set an installation path in which you can save this NetSim simulation. Click install to start the installation process. Completion. Once the installation is complete, click finish to close the installation wizard. Next comes multiple access protocol. Here we all know what is multiple access protocol. Multiple access protocol has basically three parts: random access protocol, controlled access protocol, and channelization protocols. In random access protocols, ALOHA comes the first. After that, CSMA, CSMA-CD, CSMA-CA. Controlled access protocols and channelization protocols continue further. Now comes, what is ALOHA? ALOHA is a random access protocol. It means any station can send the data and receive the data. It was actually designed by WLAN, but it is also applicable for the shared medium access. In this, multiple station can transmit data at the same time and can hence lead to collision and data being grabbed. Here, let us see, before going to next, let us see what is collision. Here, there are two computers, a computer A and computer B. When this computer A, here this is a computer A, and here this is a computer B. Now we need to see what is collision. Station B have a common medium. This is a shared medium, so this is where A and B are going to transmit the data. What if A and B send the same data? Suppose as frame, which is named as F frame, and B has also named as frame B. Just observe, is also sending the data B, and B is also sending data to A. Means this A is sending data to B and this B is sending data to A. Both are simultaneously sending the data. Then when both data meet at a time, then what happens? It leads to collision. This is called collision. Now here comes types of ALOHA. What are the types of ALOHA? There are two types of ALOHA: pure ALOHA and slotted ALOHA. What is pure ALOHA? Pure ALOHA. For example, let us consider there are four stations: station 1, station 2, station 3, and station 4. From station 1, there are two frames that are traveling within that frame. In station 2, similarly, there are two frames. In station 3, two frames, and in station 4, two frames. There will be a collision duration. Means what we have explained before. Collision means where two frames meet at a time and they collide. It is called a collision. See, here we can observe that in station 1 there is no collision, but in station 2 and station 3, frame 2.1 and frame 3.1 are meeting at the same time. This means here collision is occurred. This is called as pure collision. It is called as pure collision because in station 2, like stations are different, so it is called as pure collision. Pure ALOHA. Pure ALOHA allow stations to transmit whenever they have data to be sent. When a station sends data, it waits for an acknowledgement. If the acknowledgement doesn't come within the allotted time, then the stations wait for a random amount of time called back of time and resends the data. Since different stations wait for different amount of time, the probability of further collision decreases. Here, however, the station waits for different amount of time, like the frames that need to be sent having different times. So the number of collisions decreases here. This is an example of pure ALOHA. Here there are two stations A and B. B ends, collides, and A begin. Here A B begins and B ends here. A begins and A ends. C begins and C ends. So they travel in a particular time. Where A and B meets, their collision begins, and where A and C meets, there also A ends and collides with C beginnings. Next come slotted ALOHA. What is slotted ALOHA? Same like pure ALOHA, It was developed just to improve the efficiency of pure ALOHA, as the chances for collision in pure ALOHA are high. We saw that in pure ALOHA, the chances of collision were very high. Why? Because the stations need to wait for all the frames to send from one station to another station. So they'll not wait. All stations will not wait. They'll send simultaneously. For that to improve, slotted ALOHA was developed. The time of the shared channel is divided into discrete time intervals called slots. Sending of the data is allowed only at the beginning of these slots. Example. Here we need to highlight this point as sending of the data. This sending of the data is allowed only at the beginning of this slot. Means sending of the data is allowed only when the station ends. Then the next stations need to be started. Otherwise, they will collide. Slotted ALOHA. Here you can see it clearly. Similarly, like pure ALOHA, here slotted ALOHA is there. Station 1, Station 2, Station 3, Station 4. Here station collision duration is also represented here. Station 2 and Station 3 are collided at the same time. Means frame 1 here it begins and here it ends. And Station 2 here it begins and here it ends. But Station 3 did not wait. So it started here and ends here. So Station 2 and Station 3 collided with each other. Let us see the difference between pure ALOHA and slotted ALOHA. In pure ALOHA, any station can transmit the data at any time, but in slotted ALOHA, it is not possible. The data is only transmitted at the beginning of the time slot. The time is continuous and not globally synchronized in pure ALOHA. The time is discrete and globally synchronized in pure ALOHA. Vulnerably, time in which collision may occur is 2 into TFR, whereas in slotted ALOHA, it is only TFR. Probability of successful transmission of data packet is g into e raised to minus 2g, whereas it is only g into e raised to g. Maximum efficiency is 18.4, whereas maximum efficiency in slotted ALOHA is 36.8. Next, simulation steps. Here we can see the simulation steps. First, we need to launch the experiment in NetSim. Go to experiments, legacy networks, throughput versus load for pure and slotted ALOHA. It is only for pure and slotted ALOHA where we need to go for legacy networks. Otherwise, in experiments, there are many types of networks where we can do another types of like CSMA, CD, CSMA, CS, like that. After plotting, now we need to load the scenario for pure ALOHA, then repeat for slotted ALOHA. Like same we need to take same we need to just see the collision. Here comes the topology configuration. Drag 10 wireless nodes into the workspace, 9 transmitted wire and 1 receiver node. Like one receive is called as node 1 is the receiver. Use ADHOC link with channel property set to no path loss. Set node properties. Then here it comes the simulation setup. As we said, here is the experiment. Here we can see internetworks, advanced routing, MANET, IoT, WSN, LTE, etc. And here are the throughputs. Like for total generation, what is the time required and what are the data rate, interval arrival time, etc. This is a circuit diagram of pure ALOHA that which we have done in NetSim simulation. Here we have taken 16 computers and one sending node, and here is a receiver node. These all 16 computers are connected together and they all are transmitted and pure. This is pure ALOHA, right? So all are transmitted at a similar time. Means collision occurs. It definitely occurs. So all the collisions are transferred in this wire. Here is the output simulation. Output for pure ALOHA, it is very less. Like collision is more, and for slotted ALOHA, it is very less. Thank you.
As I already said, click on the pure ALOHA. We will get direct setup of the pure ALOHA setup network and run the simulation. We will get the application matrix and export those results into the Excel sheet and calculate the